Welcome back, sixth grade scholars, to Math with McKay. This week we are continuing on with SOL 6.7. Our focus is on area and perimeter of triangles and rectangles. Yesterday we focused on triangles. Today we will put more emphasis on rectangles and squares. The SOL objective for today is the students will solve problems including practical problems involving area and perimeter of triangles. So first we will do a review and go over the questions that were given for yesterday's independent practice. Yesterday we had to find the area of both of these triangles. Notice that for question 1, you had a triangle given, and for question 2, there was not a triangle given, so you had to draw one. For the first question, you had to take half of the base. In this case, the base was 10, so take half of 10. Half of 10 is 5, and we take 5 and multiply that by 7 in order to get an answer of 35 feet squared. For question 2, we had to do the same thing. We had to go ahead, first of all, draw our triangle so we can get a visual. Always draw your triangle whenever they don't give you one. Then we take half of the base. In this case, our base was 4 8/10. Half of 4 8/10 is 2 4/10. So we take half of that and multiply that by 7 2/10. And our answer came out to be 17 28 feet squared. So if you got those answers, great job. If not, doesn't matter. Let's continue on and learn as we go through the process. Today we're focusing on rectangles. Rectangles, notice if we have a rectangle and a square. You might say, well, a square is not a rectangle. Yes, a square is a rectangle. It is a special kind of rectangle. The difference between a square and the rectangle is that the square has 4 equal sides. All right. The rectangle has 2 sets of equal sides. And you'll notice that if we look at this rectangle, if we go across, there are 1, 2, 3, 4, 5 boxes going across, and 1, 2, 3, 4, 5, 6 boxes going down. Going across gives us your width, and going from top to bottom gives you your length. Same thing with the square. Notice that there are 2 different formulas. Though there are different formulas, the formulas are the exact same. With the rectangle, you'll use the formula A is equal to LW, which is just length times width. Remember that when you don't see an operation in between 2 letters or a letter and a number, that operation is automatically said to be multiplication. When we are dealing with the square, we'll use S squared. S squared is the same thing as side times side. Notice as we go through, when you're dealing with the square, you'll only see 1 dimension, as opposed to when you're dealing with the rectangle, you'll see 2 dimensions. All right. So we will go through and we will find the area of these 2, this rectangle and this square. Again, the definition of area is the amount of space inside of a flat 2-dimensional surface. So when you're dealing with a rectangle, sometimes you might see an image such as the 2 posted on here, or you might see an image where there's nothing in the middle of, as we'll see as we continue on. Here, if you see an image like this, you just count the amount of space, the amount of individual squares going from left to right. That'll give you your width. And you count the amount of individual squares going from top to bottom. That will give you your length. And then we will go ahead and we will substitute those numbers into the equation or the formula that we used here. A is equal to LW. So if I count in this particular one, I count 1, 2, 3, 4 going from left to right. And then we count 1, 2, 3, 4, 5 going from top to bottom. So this said rectangle has a width of 4 and a length of 5 units, okay? Then you can do the same thing with the square. You count how many total individual units are going from left to right, which should be the same going from top to bottom because a square has all equal sides. All right, so we'll focus on the rectangle and then we'll go into the square. All right, so we'll solve out the rectangle first. And remember, as I told you guys with yesterday's lesson, I always want to draw a key so I know which numbers I'm using as I substitute it back into my problem. All right, so here we have L is equal to, in this case, the length was 5. And then we have W is equal to, in this case, our width was 4. Then we go over here. All right. The area is equal to length times the width. Remember, when we're substituting in, you also have to put the operator in there. If you do not put the operator in there, it just looks like two numbers sitting right next to each other, and we don't want to have that confusion. All right. So I will go ahead and now solve. So I'll say 5 instead of the letter L. I'm substituting the number 5 in, and then times 4 instead of the letter W. And then we say, well, what is 5 times 4? Great, 20. Now, this particular rectangle didn't have specific units, so you can just say unit squared. So I'll use the letter U and then squared. All right, then we'll go back and do the same thing with the square. We're going to count how many individual boxes are going from left to right, as well as how many are going from top to bottom. If I remember that a square has the same amount of equal sides on every side, then I don't have to count it going in both directions. I can just count one and remember that all of the sides of a square are equal. So we got 1, 2, 3, 4, 5. Okay. So the formula for the square is A is equal to S squared. So instead of us using length and width, I'm just going to say S is equal to 5. So then I go over here and I say A is equal to S squared. S squared, again, we're using substitution. So instead of the letter S this time, we said that S was equivalent to or equal to 5. So now we're going to go ahead and we're going to substitute the number 5 into our formula. So A is equal to 5 squared. All right, so for those of us who may not necessarily know or we're not used to seeing it this way, all this exponent at the top is telling us to do is take the base, which is 5, and multiply it by itself 2 times. So this is also saying A is equal to 5 times 5. So A is equal to 25. Again, you always want to put units on there because they didn't give us a specific amount of units. We're going to use the letter U squared. All right, now I think I'm going to give you guys an opportunity to go ahead and practice some problems on your own. Here's 2 problems that you can go ahead and figure out the area of both the rectangle and the square on your own. Again, using those formulas. Substitute the letters. If you need to make a key, then you make your key and then go ahead. If you don't need to make a key, then that's fine. You can go ahead and just do it and just plug in the numbers and the letters. Yesterday, we also used the calculator to go ahead and solve some problems. So we'll go ahead and take an opportunity to do so as well once we finish with these. So go ahead and practice these on your own, and then we'll come back together and then see how it works within the calculator. I'm going to show you a different technique with the calculator. Just bear with me. All right, so we are going to find the area of the rectangle using the dimensions of the width being 7 and the length being 3, okay? So here, I use my key. I say L is equal to 3, and I say W is equal to 7. So then we go ahead and we substitute those numbers into the formula. The formula is A is equal to LW. Remember, that is multiplication when you don't see an operator in between the 2 letters. So then we substitute these numbers in, 3 for L times 7 for W. And then we say that the area is equal to 21 feet square or square feet. Then we go back and we look at the square itself. Notice that they only gave you 1 dimension for this one. So because they only gave you 1 dimension, remember it's a square. All 4 of those sides are equivalent to 4 7/10 of a foot. All right. So then we'll go ahead and we will substitute those back into the formula A is equal to S squared. In this case, S is 4 and 7/10. S equals 4 and 7/10 feet. So then we go ahead and we use the formula A is equal to S squared, which is equal to 4 and 7/10 times 4 and 7/10. Yesterday when we were going over and multiplying decimals, I went ahead on the side and I multiplied it out so that we can see exactly what's happening here. All right, so we're going to do 4 and 7/10 times. Now, for this way, for those of us who might get confused with how to actually multiply things out, I'm going to use two different colors for the second factor so you can see what's happening here. All right, so I'm going to say 4 and 7. All right, so just so we can see what's happening here. So, all right, so I'm going to take this purple 7, I'm going to multiply it by all the numbers in green at the top, and then we're going to switch over to the other color. All right, so I'm going to take 7, multiply by 7, and that gives us 49. So we put the 9 at the bottom, and we carry the 4. Then I'm going to take 7 and multiply it by 4, which gives me 28, and then add 4 to that, which gives us 32. I'm done with that purple 7, so now I'm going to switch over to my second color, which is this blue here, and I'm going to use a placeholder because I am no longer in that place value, okay? I'm in the ones place as opposed to the tens place. So now I'm taking the blue 4 and I'm multiplying it by everything in green, and then I'm going to add it all together once I finish. 4 times 7 again gives us 28, so we put the 8 at the bottom, carry the 2. Then we do 4 times 4, which is 16, plus 2 gives us 18, so put the 18 down at the bottom. Then we add them together. We have 9 on this end. Then we have 10. Then we have 11 plus 1, which gives us 12. And then 1 and 1 makes 2. Then we go back to the factors because we're not done. We have to check to see how many digits are after a decimal point in the factors. So we have a total of 2 digits that follow a decimal point in our factors with the combination of the 2. So then we come down to the bottom. We start from the last digit and we count 2 spaces to the left and we put a decimal point there for an area of 22 and 900 feet square. All right, so now we're going to go ahead and we are going to use the calculator. Now the calculator is the same exact thing, but the difference between this and what we did before was I'm going to now show you a different technique to where it may or may not be easier. So I'll use two different things, okay? So for this one, we can go ahead and program the calculator to tell us what we want the letters to equal, so that we can just type those letters in and then we'll get the same answer that we did prior to. So if I say that the letter L is equal to 3, now this is for the rectangle, then I come back and say, oh, excuse me, I have to hit enter first. Then I come back and say that W was equal to 7 and then hit enter. I can just use the letters L and W in the calculator and it gives us the same exact answer. All right. If I want to go ahead and program a different set of numbers, then I can go ahead and hit clear, right? And then I say L, we'll do the square, is equal to 4 and 7/10, and then hit enter. Then I can go ahead and say W is also equal to 4 and 7/10 and hit enter. Then go back, use the letters L and W, and then we come out with the same exact answer that we had with the previous ones. So it's pretty simple, pretty easy. You're just substituting and plugging in those numbers so that you can come out with the right answer. Just the same way whether you're doing it manually or whether you're using a calculator. It's the same concept, right? So now we're going to go into word problems. Typically, we see word problems and we kind of shy away because it's a lot of words and we don't really want to go ahead and actually read it out. All right. So please make sure that you read the questions and make sure that you're answering the question for what the question is asking you for. Okay. So here we're going to talk about rectangles and we're talking about Neela is making rectangular placemats that are 12 inches wide and 15 inches long. Just because they use wide and long as opposed to length and width, it is still the same thing, just using different forms of the same word, okay? So now we got to find out the area. Remember, when we're trying to find out the area, all you're doing is taking the two numbers that they give you and we substitute it in. If they don't give you an image, if you don't see anything there, go ahead and draw your image out, okay? So we're going to take this and we're going to actually carry it out. So they said that the area of the placemat, so I can go ahead and just draw a rectangle and put some numbers on it. So I would draw the rectangle. And it tells us that it is, so that would be the first thing that I do is draw a rectangle. It tells us that it is 12 inches wide. So wide, I'm going to put 12 inches and then 15 inches long. And when you're drawing your picture, it doesn't have to look cute or accurate. You just draw it and everything's going to work out the same way, okay? So now we're going to go ahead and say that L is equal to 15 and W is equal to 12. Then we go ahead and we substitute that into the equation. A is equal to LW, and we say that L was 15, so we're going to substitute 15 in, multiply by 12. Then the area is going to be 180 inches squared. All right. You might ask, how did I get 180? I just went ahead and multiplied the two numbers. So I'll take 15 and multiply, and I'll use the lattice method. All right. When you're doing lattice, based off of the digits, determines how many individual boxes you need. Okay. So there are 2 digits in 15. There are 2 digits in 12. So I need a total of 4 boxes for 4 digits. So I'll put 15 here. I'll put 12 on the side, and then I will draw my diagonals within the box. Okay. And how this works is I am going to take each one of the digits that are on the sides and multiply it by each one of the digits that are on the top. Okay. So here I'm going to take 1 and multiply it by 5 because this comes out to be the product between 1 and 5 is a single digit number. I'm going to use 0 as a placeholder, and then I'm going to put 5 here. All right. I don't like how that looks, so I'm going to use a different color. All right. So again, that is 0 and 5. Then we go ahead and we do the same thing with 1. 1 times 1, it is a single digit number. So I need 0 as a placeholder and then 1 in the second box. Then we do the same thing with the 2 and the 5. 2 and 5 gives us 10. This is a 2-digit one, so I don't need 0 as my placeholder. I'm just going to write the number 10. Then I have 2 and 1, single digit number, which gives me 0, 2. And I add up all of the diagonals. So 0, and there's nothing else in there with 0, so I'm going to put 0. Then I have 5 plus 1 gives me 6, plus 2 gives me 8. Then I have 0 plus 1 plus 0 gives me 1. So all of the numbers that are on the outside that are in green is my answer. Notice we have 180 here. We also had 180 the other way. All right. Now I want you guys to go ahead and attempt this problem on your own. Make sure that you draw your image out, label the length and the width accordingly, and then go ahead and solve out the problem. For this particular problem, I'm going to use the calculator to go ahead and solve it. So once you guys finish solving it on your own, then you will use the calculator with me to go ahead and see if your answer is the exact same. So I'll give you guys a moment to go ahead and do so. All right, I'm going to clear out my calculator. So according to this question, and we'll read it, this question states that Henry has to find the area of rectangles that has a length of 6 and 3/10 of a centimeter and a width of 11 and 7/10 of a centimeter. What is the area of the rectangle? All right, so I can go ahead and I can program it in, or I can manually type this in. So I can say 6 and 3/10 times 11 and 7/10, and my answer comes out to be 73 and 7100. So if you got that same answer, great job. If not, it's okay. You keep practicing and we will all get there together. All right. Now, here we have a square. All right. Now, you guys are perfectly fine when it comes to dealing with whole numbers and maybe decimals. But when you see a fraction, then we don't really like it. But it's okay. We will go ahead and we will take that fraction and we'll convert it into a decimal. All right. Michael is cutting out a square that has a side length of 5 1/4 inches. What is the area of the square that Michael is cutting out? All right. So notice they only gave you one dimension. When you only see one dimension, that means that we are only focusing on a square. A square, what do we know about a square? All four sides are equivalent to each other. Again, you don't see an image, so be sure to draw your image, all right? So I'm going to draw my square, and my square might not be perfect, so don't judge me. All right, all of these are equivalent to 5 1/4 of an inch. So now when we are doing this, notice, I mean, you can't really function or work with fractions the way that it is this way. If you can, then go ahead and do so. You might have to change it to an improper fraction and then go ahead and multiply it. But if not, we can just go ahead and take the fractional portion of this and change it into a decimal so that we can work with that number. So how do you change a fraction into a decimal? So I take 1/4 and I see, well, how many times can the numerator go into the denominator? When we're doing this, your numerator goes inside the house, your denominator goes outside, okay? So we will notice that 4 is larger than 1, so it cannot go into that. So you have to add decimal points and some zeros. So now you want to ask yourself, well, how many times can 4 go into 1? It can't, so we'll put a 0 at the top. And then how many times can, so now we expand the number. How many times can 4 go into 10 instead of 1? 4 can go into 10 2 times. 4 times 2 gives us 8. All right, 10 minus 8 gives us 2. Bring down the 0. Then your question is, how many times can 4 go into 20? 4 can go into 25 times. 4 times 5 is 20, which gives us 0 as a remainder. So our answer, so 1/4 as a fraction is equivalent to 25 hundredths as a decimal, right? Now we weren't only just working with 1/4, we were also working with 5. So now we take 5 and add it to 25 hundredths for a answer of 5 and 25 hundredths. Now we take that, plug that into the formula. So instead of it being a is equal to s squared, it is now a is equal to 5 and 25 hundredths squared. All right, so then I'm going to go ahead and carry out the multiplication here. Five and 5, 25, 10, 12, 25, 26, 4, 5, 10, 25, 10, 12, 25, 26. Then you add the numbers, so you have 5, 2, 16, 5, 7, 2. We come back up to the factors. We see how many digits were after a decimal point in both. Here you have 2. Here you have 2 for a combination of 4. So then we come down, we start at the bottom, we count 4 spaces. 1, 2, 3, 4. And then we can round this off to the nearest hundredth. So the area A is equal to 27 and 56 hundredths inches squared. All right, so now I want you guys to go ahead and try this problem on your own. Again, draw your picture, then go ahead and multiply out your numbers together. I'll read it. Jonathan is cutting out a square that has a side length of 9 3/10 inches. What is the area of the square that Jonathan is cutting out? I'll pause and give you guys a moment to go ahead and do it on your own. I will show you guys using the calculator how to come out with the answer. I'm going to clear it out. All right, so notice that it was a square. So with the square, it was only one measurement given. So now I can go ahead and just take that one measurement, 9 3/10, and then hit this A squared, and come out with the same thing. And then I can go ahead and do this manually. Hitting the A squared gives us exactly what we want, but I want to show you guys what actually happened. So I took 9 3/10 and I multiplied it by 9 3/10, and I came out with 86 49 hundredths inches squared. All right, guys, that wraps up the lesson. So what I want you guys to do is I want you to answer these 2 questions, and we will pick back up tomorrow. Remember, please be sure to check out Dreambox for about 10 to 15 minutes a day. Enjoy the rest of your day. Thank you.